Okay, so let's run through an example homework problem that will illustrate how to do a few basic skills. The skills that we'll cover are plotting a scatter diagram using StatCrunch and calculating a correlation coefficient using StatCrunch, and then doing a sort of what we're going to be calling a hypothesis test, although we haven't covered that just yet. But this is just sort of a basic hypothesis test where we pull a critical value from a table and we compare our statistic to that. The critical value will be at sort of a cutoff, and if our statistic is greater than that critical value, then we'll conclude affirmatively the presence of a linear relationship between the variables. So those are the three things we're going to cover. So let's get started. This problem is about the relationship between cases of Lyme disease and drowning deaths in some particular county. The first task is to draw a scatter diagram, also called a scatter plot of the data. Let's see how we can do that in StatCrunch. Then we're going to choose from options A through D here, but let's see how to produce it. So if we click on that icon, this icon here, where it says click the icon to view the table of Lyme disease and drowning deaths. Okay, so this is our data. We click on this icon up here in the upper right to open this in StatCrunch. Okay, so here's the data in StatCrunch. Here we have the first column being cases of Lyme disease, the second column being drowning deaths. Now, how would we produce a scatter plot? We can go to graph and then just go down to the scatter plot option. And we select our variables. We're going to take the first variable, cases of Lyme disease, as our explanatory variable, or our X variable, and then drowning deaths as our response variable, and just compute. Click compute, and we get the picture straight away. With cases of Lyme disease on the X-axis and drowning deaths on the Y-axis. And this is the picture that we get. Notice, what it looks like basically is we have kind of a cluster of points in the bottom left, and then a few more scattered in the upper right, kind of as we move from the lower left to the upper right. Okay, so let's go ahead and look for that pattern among the options. All right, get this out of the way. We see that pattern only exists in choice D, so let's take that to be our choice. Here, you're going to want to be careful to notice that Lyme disease is on the X-axis and drownings is on the Y-axis. Okay, that's important because if you reverse these, you might get kind of a similar picture, but not exactly the same picture, but similar. But that would be not quite right. That you need to have Lyme disease as your explanatory variable and therefore on the X-axis, and drownings on the Y-axis. All right, so let's check our answer. Okay. Next task, determine the linear correlation coefficient, also known as the Pearson correlation coefficient between Lyme disease and drowning deaths. And again, I'm going to want to open up the data and open it in StatCrunch. Of course, you can do this using Excel if you like, but there are certain it works a bit differently, and you can always ask me how to do that if you're working on it in Excel or some other software after class. All right, so what we're going to do is go to Stat, okay, and under Summary Stats you can find Correlation. So we just highlight the two variables and compute, right? And it gives us a correlation coefficient. Okay. By the way, it doesn't matter what order the variables are in for a correlation coefficient. It doesn't matter whatsoever. Okay. So they want 3 decimal places. Be careful of that. Since the fourth one is a 5, I need to round up. So that 1 becomes a 2. All right, let's check our answer. Okay. All right, next, part C. Does a linear relation exist between the number of reported cases of Lyme disease and the number of drowning deaths? Well, yes, it does. The correlation coefficient is quite high. It's positive, right? And so since the correlation coefficient 0.962 is positive, right, we say that the variables are positively associated. And just recall that, of course, a correlation coefficient can be negative, right? It's a number between -1 and 1. Had it been negative, a negative number, had this number been a negative number, we would say negatively associated, all right? And yeah, so the variables are positively associated because the value R, which is this value up here, is positive. It's a positive number. And when you think about its absolute value, of course, since it's positive, it is already its own absolute value. So that's what goes here, 0.962, right? The correlation coefficient, the absolute value of the correlation coefficient in this case is just 0.962. Had it been negative, we would have removed the negative sign to obtain the absolute value. All right, and now the question now is it greater than or less than the critical value? Well, we don't know the critical value. So how do we determine the critical value? Well, that's where we need to start to fill in these last 2 blanks here. Okay, so to know the critical value, we need to go back and remember how many data points there were. So in other words, how many rows are in the data? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 rows in the data, all right? So now we're going to look at the table of critical values, which is provided for us here. We're going to go down to, on the first column, we're going to go down to the number 12 and pick up the critical value here. Since n is 12, right, that's our sample size, the number of data, right? Next to it, we find the critical value of 0.576. I'm going to paste that in here. All right. Now we ask the question, is our statistic, right, the absolute value of the Pearson correlation coefficient, this is also called the Pearson's R statistic, is it greater than the critical value of 0.576? Yes, clearly it is greater than. It's much greater than. So that finishes off this fill in the blank problem. Okay. All right. So last question is it just asks you about like the likely lurking variables. If you think about what that is, lurking variables are variables that are confounders that are both associated, or that a lurking variable is a confounding variable that is what a confounding variable is one that is associated with the 2 variables under investigation. Okay, so the 2 variables under investigation are cases of Lyme disease and drowning deaths. So you might think about what whether or not these suggested lurking variables are pesticide control. Is that related to both Lyme disease and drowning deaths? Well, it certainly could be related to Lyme disease. Okay, so I'll let you think about the rest. Another one, the other lurking variables that are suggested are temperature and time of year. Are those possible variables that are related to both drowning deaths and cases of Lyme disease, which again is associated with bites from ticks, which occur in the summer. Okay, so I'll let you just think about that. And so with that, that's the end of the video.